Good morning. It's a chili porch video. So we'll see how it goes. Why I picked here to do this, I don't know. But so what I want to talk about is Geiger counter. This here is a Safecast Geiger counter I built as a kit. I think it's about a $600 kit now, or you can buy them assembled for about $1,500, which is about right. It takes some time to put together and test it and get some trust in its working. So now it comes with this case, which is water resistant, not waterproof. And this is what you build from this kit. I'm going to turn it on here. It's going to go through a startup sequence. We'll just watch that start up. Please focus. So it identifies what it is and who it is. The battery's at 92%. My battery's going bad. This is a few years old now. Now it's on. It's kind of tested itself. And see, it says no GPS there on the right-hand side, and I'm shaking because it's cold out here. It's 40 degrees, not too bad. So what's happening now is this little GPS chip right here is querying the universe for satellites. And until it gets a solid lock on at least 3 satellites, it's going to say no GPS. Now, I'm in kind of a shielded little area, but it's still doing its Geiger counter thing. See the counts there? 49 counts per minute. So this display is telling me how many counts per minute is happening, but it's refreshing every 6 seconds. So it's a running average, but it's a true average. So inside of this meter, right down here, this is a logging chip and a little SD card. So everything it's recording, you're seeing on the screen, it's recording to that SD card. And that is your link to the data on this chip. So until you publish that SD card data, it's yours. No one sees it but you. No one gets to peek at it. You can take and put that in a spreadsheet and analyze it. You can graph it. You can chart it. If you have a lot of data, you can map it yourself. There are ways of doing this. There's some other applications that support doing a lot with this data. It's really cool. It's developed by a person out of Germany. And if you're into software, analytics software, that is a relationship to try and build. But what you really do is you just pull this little chip out, and somehow you get it into that file. It's a flat file. You get it into your computer or your cell phone, or however you do it, and you upload it to the Safecast application server, where it becomes a historical record among many, and is presented on the Safecast map to anyone that wants to see it. So right now, okay, you can see some little lights flashing here and there in between my shaking. And it just means those chips are working. Those are kind of heartbeat things that you look for if you think you've got a problem. So now you can see the no GPS has gone away. All right, it's locked onto its satellites. It's found something. It has an idea where we are. But with that, because of this chip, and this stuff's dated actually. Well, a lot of the things are dated in here. It is an old technology, although it's neater than shit. So there you go, 43 CPM. Now the reason it's reading 43 is because I have it set on this tabletop. Now what I'm taking right now, I label when I store this data, if I store it. Sometimes I just upload it and look at it to see if it looks like yesterday's. I've recorded stationary records, stationary log files over months and years now of just this location. It does a few things. It tests my location. I've got solid baseline statistics about the waveforms that we see here, the averages we see here. I could go back and try to tie those to atmospheric events or whatever else. So usually, I'm going to show you this. See, this doesn't fall out of this case. The case helps protect it from vibration and everything else, but usually, yep, falling over here. I'll hang it, I don't know if I showed that well or not, but I'll hang it up here and leave it running. And it just runs until the battery dies and it shuts itself down, which is about 18 hours, depending on how much I've used this battery up. I haven't been timing it lately. I don't look at the log file durations. The log files that it generates end up being huge. And I mean huge because it is taking 6 records a minute. It logs GPS, it logs actual counts per minute. It logs something called a CP5, which is, instead of counts per minute, it's counts per 5 seconds. That's why I'm saying there's 6, or it's logging data every 5 seconds. What am I saying? I'll have to go back and review that. So anyway, back to the SafeCast meter. I talked to this chip. That's a data logging chip. This chip is a GPS chip. The CPU is buried under here. This is... Sorry, I'm thinking about it for a second. This is a chip, I think it's called a BLE chip. No. But yes, it is. It's the BLE chip. And you can see right now there's no chip in there. And that's for 2 reasons. If you remove the chip, it increases the battery life about 3 hours. And one of the things I would do with this, so I could get that 18-hour run, I would take and set it by the side of railroad tracks and just let it sit there and try to hear when the trains go by. And then I'd go back the next day and recover it and take the log file and look and see if it told me anything different. And basically, I've not caught a train carrying radioactive materials that this unit measured. See, I'm qualifying a lot of what I'm speaking to, because as good as this thing is, okay, you can see it's still reading really high. But again, that's that tabletop. We get a dust in this town. You can see it on my fingers. Now right here it's white because it's mostly cigarette ash. But we get a dust here that is a black soot. Okay, and it's continuous. Clogs the air filter up in the house. And this is an artifact of Portland air quality, right? Because that black soot, this hasn't been a volcano lately. It's not volcanic ash. So yeah, this guy is just sitting here reading. Now I'm not going to save this log file. One of the I meant to mention while it was happening, the system gets its time and date from the GPS chip. So if I had been paying attention, I would have written down the time and date when it started up, because that tends to be kind of a random number. And after it gets the lock, you'll see it correct. So 2512, what does that mean? That's the 25th day in the 12th month, the 1744.32. That is GMT, or I don't call it GMT anymore. But basically, we are, in America, we're minus some number of hours from GMT, which is basically Greenwich Mean Time, or it was. So it's got a really accurate clock, but the first set of data, it was logging when it had the wrong time and date. And that first set of data is garbage. If I do this, this switch right here sets whether I'm logging to the file or not. And it's going to change the display mode on the screen. So right now it's just showing you counts per minute, and it has a Sieverts transition there too, 0.126. The average here for an air reading, not a countertop reading, the average here is about 31 point something counts per minute. And that is an average over millions of statistical points. So I'm pretty confident in that. And right now it's reading 45, and I could explain why. But I do have days where the average is up in the 40s or 42s. Again, sitting on a table is a little bit different, and you kind of need to know how your meter works really well. So you go off on your merry way, and the meter spends a day with you. Attached to your hip is where I wear it when I'm out. Even when I'm on my bicycle, it's still at about that hip height. Let's call it gonad dosage, right? How many rems are your balls getting, or your womb, or your ovaries? So 29 CP, again, that's close to 31, that's closer to what I expect. So we've got something going on. I have the case open now. Sometimes that makes a difference depending on where you are. But basically, you just turn this thing on and you go take a hike until the battery's dead. You turn it off, you bring it back and charge it, making sure it's off while you're charging it, right? See that sway? 26, I'm going 26 to 42 CPM. So when the average comes out in the statistical analysis of this, again, that's where you get to that 30, 31, 32 count for an average. Again, it's logging data right now. It's not recording my voice, it's recording counts for every 5-second duration from the detector. And the detector, so the detector is always being collected from, and the software putting the display information together is doing some summation for every 60 seconds worth of data, but it's doing it every 5 seconds. Back to the display. That little doodad right there is elevation in kilometers. You can't change that. Again, time and date, and this is how long the meter's been running, so it's got 11 minutes of data. Now what I'm going to do is, I pointed to this little switch before. This changes the display mode from counts per minute. It's going to cycle through different, different reading types you can get from a detector of this type. So I flip the little switchy-do up, and now the display is going to switch through different readings. It's still displaying based on that 6-second, but, oh, I'm sorry, based upon 1 minute averages, but it's updating every 5 seconds. So again, it's displaying, these are relative dose estimates. Don't hold these as facts. You see it's displaying 100 or 0.12 microsieverts per hour. Uh, 42 CPM for this 1 minute. There was a becquerel. Waiting for it to scroll. There it is, 178 becquerels per meter squared. That was a squared, right? Yes, meters squared. So that's a huge number, right? That's a lot of becquerels. Again, that's a very well estimated number because of the precision of the instrument. So that's what the front side of this is doing. It's not logging this data right now. So this mode is what you would want to use if you're just surveying around. If you take the meter out of the case, it becomes infinitely more alpha and beta sensitive. Huge orders of magnitude more sensitive to alpha and beta. And it's displaying very quickly. So using this, looking at those counts, you can use it as a detector to locate a source. Instead of being a distributed source, you can use some tools and a little bit of time to locate the source of radiation with this. So I don't use this much, but you can. I don't use it much because it's not logging data. But when I do these tests, especially with a meter out of the case, I a lot of times don't share that with Safecast because it's not the data that they want collected for display on that. It might get rejected even because it looks really gross. If I play with a radiation source, I'll have huge counts. And I want it in the log file because I'll go look at that somewhere else to see what it means. And I haven't found anything. So that little file, that's yours to keep or do as you want or please with. This BLE chip is the Bluetooth chip. And what it allows you is to use your cell phone and see what the meter's doing. And that is hugely useful. And I do wish it worked because it's used like if you do a bicycle survey, you set your cell phone up on the handlebars and start pedaling. And that way you can glance down and see what's going on, and you can look back to know if you want to go back somewhere. That's the most important thing because you need a data density. You need a lot of data to know what you're talking about, or it's just a blip in the radar, you know. But if you can go back and walk up on a source and get that data logged and be able to show it, you'll see the increase as you get closer on the maps. Because this is logging that quickly. You have to zoom way in to see it, but that's how good this meter can be in its how you use it. So this takes a lot of time. I'm going to get to that. See, I'm already 17 minutes in and I haven't gotten very far in this, but anyway, that's the front side of this thing. I'm going to put it back into logging mode, so everything I do is going to go into this data card, and it creates the file based on the date of the data collection is the file name. So it's a weird naming convention, but once you start looking at the files, you'll have to figure it out. Again, if I had that Bluetooth chip, you can use your phone to collect the data set and upload the data set from your phone instead of having to play with this chip. It's a little bit of, time to go through those steps, and you have to make sure that you're connected and the cell phone's nearby, so it creates some constraints when you do that you might not want to worry about. But for the bicycle trip, it's perfect. For the car trip, it's perfect. You can put the meter outside on your window, like they recommend for car trips, and see what you're reading. And in the case of a lot of my surveys, I would turn around and go back, so you've got miles of data, thousands of data points in any place of interest that I was interested in. If you look at the Portland area map, you'll see thousands of data points. So, yes, wow, it's a long video, 18 minutes, and I'm not even half done. So there's the meter. I just closed the case. This is the detector, all right? Safecast.org, but this is an LND detector. It's well characterized and classified, and you can see this. I just noticed this. See this plate not lining up? This gold-plated plate is an EMF shield. It helps shield the detector from spurious radiation from transformers or microwaves or anything else. It is almost a requirement on the device. It doesn't do much to the resolution of it. It's not hiding anything. It's keeping signals you don't want out. Another thing is there's a coating on that detector. Okay, now it's under the plastic and it's supposed to be behind that. So I've got to take this apart and re-glue that. This thing has been used. It has miles on it, and abusive miles, shaking on a bicycle, shaking hanging out a window down a dirt road. So it has done very well by me. That detector, again, I've gone over in other videos, has very specific characteristics. That's why it's kind of important that this meter, you get some respect for the data it's collecting if the person collecting the data isn't cheating, isn't playing games, isn't uploading silly data. They've been playing with their smoke detector and they want to, jack with SafeCast data. It's hard to, you will get called for it. So that's the back side of the meter. Again, it's on, the cell, it's doing what it does. Oh, I was going to say, the surface of the meter, the surface of the detector is a quartz, and it's brittle. So you really don't want to be touching it much, but it can be dusted off. That little gold thing can be removed if you need to decontaminate your meter for some reason, and I can't think of any reason. Yeah, I'll give you my phone number if you think you've got a contaminated meter, and I'll talk you out of it. So that needs to be corrected because that's the EMI RFI filter. I have used it. I've noticed nothing walking by huge high voltage transformers, so it's still doing its job, and it probably hasn't been out of place long, but I'll super glue that back in place. So one of the things with this, I mentioned big data. You need huge data sets for this. And in order to collect good data, you have to have what do you want to call them? You have to have some big data in one location so that you can make sure, if you're thinking there's a trend going on, that it's not atmospheric and that it's local. So you've got to establish these local average readings to know when you get into a deviation. So right here, 31 counts per minute in the Portland area is what I expect unless I'm near a medical patient, or I haven't actually found any place here that is of concern using this type of meter. Again, it's just looking for radiation. It's not looking for heavy metals or the other contaminants of concern, other pollutions. This is just one tool, and that's it, logs data. But when you go out for a hike, a walk, the slower you travel, the better your data, because you're collecting more area, more data about an area. So you can find places around Portland, you have to zoom way in, where I've done patterns maintaining about a 3-meter distance across a field, just crisscrossing fields to see if maybe somebody dumped a radioactive source or buried it and thought they could get away with it. And it's like it's the worst gold, it's the worst, what do you call that, mudlarking? Yeah, hobby there is. Because if you do start to see weird things, you've got to go back and normalize. If you look at the Hanford area, over half of the data about Hanford is from me, or was at the time, because I went and visited the site and went on two distinct, one tour was a parks tour, one was a Department of Energy tour, and I took my personal protection equipment with me, turned on, so it logged data. On the federal site side, which this is a personal protection device, so. But what I found in some locations there was an anomaly in readings. You could see it very clearly on the meter. So in the case of the Hanford B reactor, I went back a second time, another day, some weeks apart, and redid the survey. Tried to pay a little more attention to time and location and see if I could but I hadn't, that, to me, that area, if you zoom in the Hanford B reactor, you can find it. If you zoom in and you see the color pattern there, there is a lot of noise going on. The meter was very noisy in that location. So to see if it meant anything, I had to go around that area and make sure this wasn't an artifact of the area. So I drove around the whole reservation a few times in a few different directions and roads to see if those anomalies were there. If I had to see, so this is over, this is a couple of weeks worth of time and driving over a month period to log this kind of data, and some bicycling. It was pretty hot to be out on a bicycle, so I did cheat. Anyway, this is a long video. It's going to take a long time to upload. Hey, if you want to borrow this, if you're planning on tripping, we could make arrangements. Let me know.